Okay, Bismillahirrahmanirrahim. We are going to discuss that what are increasing and decreasing functions, and also we'll be telling the values of x for which a function will be increasing or decreasing. Now, when you define this, you will have to go back to the time when you were given a domain, okay, of a function, and you're finding the range of that function. Okay, like for example, if I give you that, okay, this is f of x that is equal to, let's say this is 2x plus 3, and your x is all real values. Can you tell me what would be the range of this function? That will be all real values, okay, because you know that this is the one-to-one function. It is a linear function, so its range is going to be all real values. Okay, so I'm putting this greater sign here, so this will be all real values. Now similarly, if you have, let's say there is another function which is g of x, okay, and let me write this in completed square form. This, let's say this is x minus 2 whole square and then plus 3, okay, and now its domain is again it is all real values. Again, the domain is, I'm not giving you some confusing or tricky questions here. So what would be the range of this function? Very good, mashallah. So this is basically like, you know, you will be having the sketch in front of you, okay? And this point is 2, 3. So the range over here is greater than or equal to 3. Okay? So now we have to see that if your function is increasing or decreasing for the given set of values of x, okay? So, for instance, if I ask you people that let's take the values of x more than 2. If it is x is more than, it is greater than or equal to 2. So what do you think of this function? Is that increasing or decreasing? It is increasing because, you know, this curve is going upwards, okay? And before this 2, if your x is instead of more than or equal to 2, if your x is, let's say it is less than 2, so you will see that this is going to be a decreasing function because the curve is going downwards, okay? Now, you can determine this without having this sketch with you through this calculus, okay? Remember, you guys have already learned how to find the gradient of the curve through that differentiation. Okay, na? Now, if I draw different tangents on this part of the curve, which is after this x equal to 2, you will see that all these tangents, they will be positively steep. And they're going to be positively steep. That means these tangents gradients are positive. So you can note down in your notes that if a function is increasing, then the tangents on the graph of that function will always be positively steep. They will all have the positive gradient. So for increasing function, you can say that your dy by dx is going to be positive. Okay? And for the decreasing function, while for decreasing functions, you can note down that dy by dx will be negative. Okay? So if you differentiate this g of x, you will get, look at this, what will you get? This g dash of x over here, if you people are now good at your differentiation, that will be 2 into x minus 2 into 1, and then 3's derivative is going to be 0, okay? If you want to see that for what values of x your function is an increasing function, so you will put this derivative, this 2 into x minus 2 greater than or equal to 0. And you will see that this solution is going to be x is greater than 2. That is what I was telling you. And if you want to determine the values of x for which your function is a decreasing function, you will put the same gradient less than 0 here. This is 2 into x minus 2. That will be negative, and you will get that x is less than 2. So the function is decreasing if you have the values of x less than 2, and similarly increasing for the values for more than 2. Okay? Now let's go back to the exercise, okay, and try the questions from there. Okay, so we have this exercise here. It says find the set of values of x for which each of the following is increasing. So your first step will always be, you will be finding f dash of x. Okay, or if it is y equal to something, so you will have to find this f dash of x. For all the parts of this first part, you will put that greater than 0, and you will get those corresponding values of x. And similarly, for the second question, you will be putting f dash of x less than 0. And please remember those methods, the way you people solve the quadratic inequalities. Okay, you will be getting quadratic inequalities here. Okay, challenge, practice it. Okay, sixth question, where we have to show that the given function is an increasing function. Okay, so I will be writing this first of all in the form where I can differentiate this. So I need to split this. Guys, you must be knowing, you must know this very well, that for what expression, what technique has to be used. Okay, this is x minus 4 over x. Now I can differentiate this f dash of x. That is going to be 1 plus 4 over x squared. Okay, so you see that now you have to show that this is really an increasing function. Can there be any value of x for which this f dash of x can result into a negative image or negative value? No. So you see, because of this x square is always going to be positive. This implies that f dash of x is always going to be positive. Okay? That is going to be more than 1. Okay? So that is why this f of x is an increasing function.